Welcome back to our session. We're still talking some of the reactions in aqueous solutions, but now we want to focus our attention on the solubility of some of these substances or these solutions, under different, conditions. That's what we want to look at now. Right. So now we'll look at the types of reactions that take place, but have to do with the solubility. We'll also take a turn and look at precipitation reaction and try to understand exactly how precipitation reactions actually occur, bearing in mind that some of the, substances are soluble and some are not. Right. Okay. Now, some of the terminology that we'll continue to refer to a lot in our discussion are soluble. And if we're saying something is soluble, we're actually saying it has the ability to dissolve within a particular solvent. And then the opposite of that then becomes insoluble, right? So these are some of the key terms. Now, if we talk about a substance being an electrolyte, this substance must be ionic, all right? Electrolytes are actually ionic substances, right? Now, what's so special about these substances is that it has a lot to do with the property of electrical conductivity. So, in essence, an electrolyte is actually a solution with a high concentration of ions. So it's actually an ionic solution that actually conduct electricity. So it means that if we have a solution that we describe as an electrolyte, it simply means that electric charge or electricity can pass through that solution. Why? Because there are free moving ions in that solution. Hence we are saying that all electrolytes are actually ionic substances, right? That's a very, very important chemical property of ionic substances. And then now let's look at solubility and conductivity, right? Conductivity is, in this case, we're talking about electrical conductivity, right? We are talking about electrical conductivity. So a solution that has got high conductivity is formed by soluble salts. And these salts are actually ionic substances, right? So there's a strong link between chemical composition, solubility, as well as conductivity of a given substance, right? And then also the solubility rules, which is very, very important. We're saying that all salts, it means, you can list them from group 1, you've got your lithium, you've got your sodium, you've got your potassium. These are group 1 metals, and ammonia are all soluble. So any salt that is based or is made up from a group 1 metal is actually soluble. Okay, that's solubility rule number 1, right? And then also all nitrates are actually soluble. So we're talking about what? Potassium nitrate as an example. Okay, it's very soluble. All right, as long as it's a nitrate. We can also talk about magnesium nitrate for argument's sake, because we are saying all nitrates are actually soluble. Okay, so take note, as long as the salt is a nitrate, it is completely soluble, right? Okay, and then again, in as far as the solubility rules, we are saying all, take note of all, halides are soluble except for silver, lead, and mercury. And when we talk of halides, this draws our attention to our very, very important tool, which is the periodic table of elements. What elements do we refer to as halides? Okay, maybe that's the big question that we need to actually ask ourselves. So if a substance is a halide, it means it's an element that occurs in group 7. So all group 7 elements are actually halides. What are halides? Examples are your fluorine, chlorine, okay, bromine, as well as iodine. These are halides, which are in group 7. So there is something special about group 7 in terms of chemical properties, okay, which appeals also to the solubility of these substances. Okay, so if we are talking about all halides, we're talking about these substances, except in silver. If it's a silver halide, we can talk about silver chloride, okay, for argument's sake. Okay, chemical formula, very important. We can talk about silver bromide, all right? We can talk about silver iodide. It means these are actually insoluble because we are saying these are actually exceptions, right? Okay, and then again, all sulfates are soluble except for barium. So sulfates are these salts that contain, the sulfate, polyatomic ion. So if we're saying barium sulfate for argument's sake, okay, barium sulfate as a salt, this is insoluble. All sulfates are insoluble except barium, lead, and mercury. So the sulfates of barium, lead, and mercury are actually insoluble. Hence, we are saying that these are our exceptions, right? Okay, and then now let's look at the carbonates, right? And the moment we start to say carbonate, we need to draw our attention again to chemical formula because it will play a very important role in as far as us understanding or predicting whether these substances are soluble or not, now that our focus is on solubility of salts, right? So chemical formula, we cannot overemphasize the importance of that. It's very, very important that we understand the chemical formula. So all carbonates are insoluble except the carbonates for group 1 metals and ammonia. Okay, they are insoluble. So if we have, let's say for argument's sake, sodium carbonate. Okay, the carbonate ion is CO3, 2 minus, okay? And then let's say, for example, we've got sodium, which is group 1. Now, if we're saying all carbonates are insoluble except group 1 metal carbonates. So a metal or carbonate of a group 1 can be sodium carbonate for argument's sake. So the formula becomes NaCO3. Okay, then we need 2 of those because that's 2 negative. Then this is actually soluble. So this is as far as the solubility of these particular substances is concerned. So before we do any reactions, we also need to take into account the solubility rules as we have discussed them. So in as far as solubility rules is either we know them or we don't. But our understanding of these solubility rules will actually help us to predict in as far as these reactions that take place in aqueous solutions are concerned. Then we're able to say, okay, as long as it's a metal from group 1 and it forms a carbonate, is that carbonate soluble or insoluble? For us to actually arrive at a conclusion, we need to understand the solubility rules. And also, the issue of chemical formula is very, very important. We cannot overemphasize on that. Now, when we talk of precipitation reactions, when we have 2 solutions of soluble salts which are mixed together, they form an insoluble salt, and that settles at the bottom of the container, and then it forms what we call a precipitate. So when a precipitate is formed, that type of reaction is referred to as a precipitation reaction, right? So a reaction that produces a solid which is insoluble is called a precipitation reaction. So in precipitation reactions, we are looking at also applying these solubility rules, right? Okay, let's look at an example here. Barium chloride and silver nitrate are mixed together, okay? We've got barium chlorides, these are salts. Silver nitrate and barium chlorides are salt. What do we get? We get silver chloride and barium nitrate, okay? Now, what happens here? This is a precipitation reaction. And how do we represent a precipitation reaction? We would have something like this. We know that a halide of silver is insoluble. So this will be solid, and then the color of this precipitate is what is going to tell us which halide is involved. So this is a typical example of a precipitation reaction, and the reaction has already been balanced. But for us to balance the equation of reaction, we need to have the correct chemical formula, right? Which is very, very important.